A necessary flag before the script. I can't browse the web in this conversation, and I have no record of either NeMo Switchyard or Nemotron 3.5 Lightning in NVIDIA's Chromic line. They may be genuine releases after my knowledge cutoff, or the premise may be inaccurate. Given this channel's stated standard on terminology and number discipline, I won't invent launch dates, benchmark figures, API names, or executive quotes for a product I can't verify. Below is a script that treats the Switchyard Nemotron 3.5 claim as reported but unconfirmed, and builds the substance on documented, checkable material, NVIDIA's existing inference stack, and the published research on model routing. Verify the repo and model card before publishing. A claim is circulating in developer channels that NVIDIA has shipped an open-source routing library, reportedly called NeMo Switchyard, alongside a new Nemotron model release, a layer that no longer sends every request to one model, but decides per request which model should answer. We need to be precise about what we can and cannot confirm. As of this recording, we have not independently verified the existence of that repository, its license, or its release date. Treat the specific product name as unconfirmed. What is entirely verifiable is the architectural problem it would solve, and that problem is already reshaping how production AI systems are built. Here is the documented context. NVIDIA has for several years published the Nemotron family of open-weight models, including the Llama Nemotron and Nemotron Nano, Super and Ultra tiers, explicitly positioned as a range of sizes rather than one flagship. NVIDIA also ships NeMo as a training and customization framework, IM as containerized inference microservices, and Dynamo as a distributed serving layer with request scheduling components. That is the shape of the stack. A routing library is the logical missing seam. Whether it landed under the name Switchyard is a question for the repository, not for us. The design pressure behind it is not in dispute. At the architecture level, a router is a pre-inference decision layer. It sits between your application and your model endpoints, and it does four things. It scores the incoming request, usually with a small classifier, an embedding lookup, or a learned reward model, to estimate how difficult it is. It reads a policy, your latency budget, your cost ceiling, your quality floor. It selects an endpoint, and it handles fallback when that endpoint returns an error, a timeout, or a low-confidence answer. Everything else is implementation detail. The core insight is that model selection becomes a runtime decision, not a deployment time constant. For 2 years, most production code hard-coded one model string. That was defensible when there were 3 serious options. It is now a structural liability for 3 reasons. First, price dispersion. The cost gap between the cheapest capable model and the frontier model for the same task is often more than an order of magnitude. If 90% of your traffic is classification and formatting, you are paying frontier prices for clerical work. Second, deprecation risk. Model endpoints get retired on vendor timelines, not yours. Third, latency. A single model gives you one latency profile. Your users have several. This is not speculative. It is a documented research line. In July 2024, researchers, including Isaac Ong and colleagues associated with LMSYS, published RouteLLM, which trained routers to direct queries between a strong and a weak model. The paper reports cost reductions exceeding 85% on MT bench, while retaining roughly 95% of the stronger model's measured performance. Those figures are the author's own, on their own benchmarks, not a general guarantee. Earlier in 2023, Lingzhao Chen, Mate Zaharia, and James Zhu published FrugalGPT, describing an LLM cascade. Try the cheap model first, escalate only when a scoring function judges the answer inadequate. The reported savings were substantial in specific settings. Those 2 papers describe the 2 dominant routing patterns, and the distinction matters if you are building. A cascade is sequential. You call the cheapest model, evaluate the output, and escalate only on failure. It is cheap on easy traffic and adds latency on hard traffic because hard requests pay for every failed attempt. A classifier route is upfront. One small, fast model decides before any generation happens. Latency is predictable. The cost is that your router can be wrong, and a misrouted hard question produces a confidently poor answer with no escalation path, unless you add a confidence gate, at which point you have quietly rebuilt a cascade. Compare that to what most small teams actually run today. The common pattern is a length heuristic. If the prompt exceeds some token count, use the bigger model. Below it, use the cheap one. Wrapped around that, a try-except chain. On error, retry against a different provider. That works until it doesn't. Prompt length is a poor proxy for difficulty. A short arithmetic word problem can break a small model, and a long document summary may not. The failback chain has no memory, so it retries into the same failure. And the routing policy lives inside application code, which means changing it requires a deploy. If you want to adopt routing in an existing agentic workflow, the migration is narrower than it looks. Consolidate every model call behind one adapter function. That is the only invasive step, and it pays for itself regardless of which router you choose. Then move the policy out of code and into configuration.
Before you trust it, build an evaluation harness on your own traffic and run the router in shadow mode, logging its decision while the old path still serves. Measure quality, cost, and latency separately.
And instrument the routing decision itself, because an unobservable router is an unfixable one. The strategic implication is larger than any single library. If routing becomes standard infrastructure, the model stops being the product and becomes a component. Whoever controls the routing layer controls which models get called, and a vendor shipping both the router and the model family has an obvious interest in the defaults. Open sourcing the router is how you win that position credibly. It is also, genuinely, how portability gets built. So the caution stands. If NeMo Switchyard exists as described, read the license, read the default policy, and check whether third-party endpoints are first class or bolted on. And if it doesn't exist yet, something like it will. The architecture is already inevitable.